Shade the solution set for the given system of inequalities. 2x plus y is less than or equal to 3. X minus y is greater than or equal to 0. So, starting with the first inequality, the boundary line is 2x plus y equals 3, and it's a solid line because of the equal to part of my inequality symbol. In this particular case, we can graph this as y equals minus 2x plus 3, which is the slope-intercept form. It tells me that it has a y-intercept of 3, which is right there, and the slope is negative 2, which we can deal with as negative 2 over 1. That means we go down 2 and over 1. That would give me a second point, which is the point 1, 1. I now draw a solid line coming down through those 2 points. In terms of which side is the side to shade in, well, we could do a test point of 0, 0. If we take the test point 0, 0 and we substitute it in here, we would get 0 plus 0. Is that less than or equal to 3? And it checks. So therefore, we will shade in that half plane. So let me shade it in with horizontal lines. Okay. Next, we need to graph x minus y greater than or equal to 0. So we graph x minus y equals 0. And that's the boundary line. It'll be solid because of the equal to part of my inequality. And once again, if I add y to both sides, I get the equation y equals x, which means that it passes through the origin and it has a slope of 1, which means I go up 1 and over 1 and happens to intersect the other line at that point 1, 1. It is a solid line, so I draw my graph as a solid line passing through those 2 points. Now, this time, I cannot select 0, 0 as a test point, but let's simply select, for example, this point, 3, 0. So I substitute 3 for my x, 0 for my y, and 3 is certainly greater than or equal to 0, which means I shade in the half plane that contains that point 3, 0. So I shade in below the line. Now what I see is that my solution is the intersection of these two graphs, which is the overlap. So my boundary lines are these two, and I shade inside, and that's my solution to that system of inequalities.